All right, welcome. Today, we are diving deep into JavaScript. You know, the language that makes pretty much every website you visit, well, do things. If you've ever found yourself wondering how the modern web actually works under the hood, then you are in exactly the right place. You know that feeling, right? You click a button and a menu just smoothly slides into view? Or you're scrolling down a page and poof, new content just appears out of nowhere? That's not some kind of web magic. Nope, that's JavaScript. It's the engine turning a flat, boring page into something you can actually interact with. So let's break it down. If you think of a web page, HTML is the skeleton, right? It gives it structure. CSS is the skin, the clothes, the cool haircut. It's all the styling. But JavaScript, that's the nervous system. It's the brain and the muscles. It's the part that lets the website respond and react. It's truly the language of action on the web. Okay, so before we get into the really cool, complex stuff, we gotta cover the fundamentals. We need to understand how JavaScript actually thinks. And it all starts with three core ideas: variables, different types of data, and of course, functions. First up, variables. The easiest way to think about them is as labeled boxes where you can store information. Now, in modern JavaScript, you're mostly gonna see let and const. You use let for a box whose contents might change later on. And you use const for things that you want to set once and never, ever change. It's a great way to prevent accidental mistakes in your code. So what do we actually put inside these boxes? Well, the most basic ingredients are what we call primitive data types. You've got your numbers, your text, which we call strings, and booleans, which are super simple, just true or false. And then we have these two special ones, null and undefined. Both kind of mean nothing, but in very different ways. And yeah, this trips up everyone at first. Here's the deal. Undefined means we've made a box, but we just haven't put anything in it yet. It's just empty by default. Null, on the other hand, is totally different. That's when you, the programmer, deliberately open that box and put something inside that says, this box is intentionally empty. It's a small difference in spelling, but a huge difference in meaning. And finally, we have functions. If variables are the nouns of our language, then functions are the verbs. They're the action takers. You basically write a recipe of instructions. You give that recipe a name, and from then on, whenever you want to perform that task, you just call its name. No need to write it all out again. Super efficient. All right, we've got the basics down. Now, let's get to the really juicy part. We're going to look at the central challenge of JavaScript, a core part of its design that, weirdly enough, is both its greatest strength and its biggest weakness. See, at its heart, JavaScript is what we call single-threaded. I want you to imagine a chef in a kitchen who can only cook one dish at a time. They have to start the dish, cook it completely, and put it on a plate before they can even glance at the next order. That's JavaScript. One task at a time, line by line, no exceptions. Now, you can probably see the problem here, right? What if our chef gets an order for a slow-cooked stew that takes 3 hours? Does the entire restaurant just stop? Does nobody get a drink or an appetizer for 3 hours? For a website, that's like saying, hey, we need to download this huge video file. Does the entire page just freeze and become totally unresponsive while it waits? Well, thankfully, the answer is a big, fat no. And the way JavaScript solves this is honestly one of the most brilliant ideas in all of programming. It has a special system in place to handle these long-running tasks without bringing everything to a grinding halt. Let's pull back the curtain. So, welcome to our restaurant kitchen. This is our metaphor for something called the event loop. The first piece of the puzzle is the call stack, and you can think of the call stack as our chef, our very focused, one-track-minded chef. The chef is actively working on one recipe at a time, and you cannot distract them. This is where all the immediate synchronous code gets done.
But what about that 3-hour stew? Our chef is smart. They're not just going to stand there and stare at the pot. They're going to put it in an oven and walk away. These ovens are what we call web APIs. They're like background helpers, perfect for time-consuming things like timers or fetching data. They do the work on the side, freeing up our chef to whip up some quick appetizers.
Now, when the oven dings and the stew is ready, what happens? A waiter doesn't just run into the kitchen and interrupt the chef, right? No, that would be chaos. Instead, they place the finished dish in a waiting area. In our world, that's the callback queue. It's just a line of finished background tasks, all patiently waiting their turn for the chef to be free.
So who runs this whole show? Who makes sure it all works? That would be the event loop, who we'll call the restaurant manager. The manager has one simple, constant job. Keep checking on the chef. Are you busy? Are you busy? Are you busy? The instant the chef finishes their current task, the manager looks at the waiting area, grabs the first finished dish from the line, and says, "Okay, serve this now." And that's it. That's the secret to how JavaScript juggles everything and stays so responsive. Now, in the old days, managing this system could get, well, really ugly. If you needed task A to finish before task B, which had to finish before task C, you'd end up nesting functions inside of functions inside of functions. It created this horrible drifting pyramid of code that developers called callback hell. It worked, but man, it was a nightmare to read. To clean up that mess, modern JavaScript gave us promises. And the analogy is perfect. Think about ordering a pizza. When you place the order, you don't get the pizza right away. You get a promise of a pizza. The .then part of your code is your plan for what to do when the pizza finally arrives. And the .catch part, that's your backup plan for what happens if something goes wrong and the delivery fails. It's a much cleaner, much more human-readable way to handle these future events.
Okay, we've seen how JavaScript handles things happening over time. Now let's look at another bit of magic that has to do with memory. It's a concept called closures. And to get our heads around it, let's talk about something simple: a cookie jar.
Imagine you have a big function, and inside, it creates a variable, our cookie jar, with 5 cookies. Then, that function returns a brand new, smaller function whose only job is to eat a cookie. Now here's the magic trick. Even after the big function is totally finished and gone, that little eat cookie function still remembers the original cookie jar. It holds on to that memory. It has closed over its environment, which lets it keep track of how many cookies are left, creating its own private, lasting memory. It's incredibly powerful.
So now that we kind of get how JavaScript deals with time and memory, let's look at a couple of awesome modern features that just make writing code so much nicer and easier. Let's go back to that pizza order. An order might have tons of details: the type of pizza, the size, the toppings, the address. In the old days, you'd have to pull each piece out one by one on its own line. But with destructuring, you can just say, hey, from this order, I only need the pizza and the size, and it plucks them out for you into new variables. It's just so much cleaner.
And then there's a 3-dot operator, which is like a programming Swiss Army knife. Used one way as the spread operator, it's like opening a box of ingredients and spreading them all out to add to a new recipe. But use it another way as the rest operator, and it does the exact opposite. It's like gathering up all the leftover ingredients and putting them all together into one container for later. Same symbol, 2 very powerful jobs.
So let's do a quick recap. What do you really need to remember? 1. JavaScript is the thing that makes websites interactive. 2. It can only do one thing at a time, but it has a brilliant system, the event loop, to juggle lots of tasks anyway. 3. Promises saved us from callback hell and made asynchronous code way easier to read. And finally, modern features are constantly making the language cleaner and more powerful.
So there you have it. You now have a real understanding of the engine that powers pretty much the entire modern web. From a tiny button animation to a massive, complex application, the core logic is all the same. So the only question left is, now that you know how it works, what are you going to build with it? Thanks for joining me.